Hello and welcome back. This is a video for section 7.2, and this is rational numbers as exponents. And this is a part one video. I wanted to go through and explain how the laws of exponents work. Okay. On the next page, I just give you what the laws of exponents are. Okay, so this tells us and goes through why we have those laws. Okay, so the first one that I want to do is the it's called product of powers. Okay, so let's write this down. Let's write down product of powers. Okay, and so what I want to do is just kind of look at something. Let's say we have, say, 3 squared times 3 to the 4th power, okay? And what I want to do is simplify this, okay? But I want to show you how this works. So if I were to take 3 squared, okay, and that's going to give me 3 times 3. Okay, multiplying 3 by itself twice. Okay, then if I take 3 to the 4th power, that means I'm multiplying 3 again 4 times. So 1, 2, 3, 4. Okay, so now the question is what am I doing here? Okay, how many times am I multiplying 3? Okay, and so what we get is if I take 3 squared times 3 to the 4th, then that's going to give me 3 to the 6th power. Okay, and what I'm doing here is I'm adding my exponents. So adding my exponents. Okay, so I could write this, if I had 3 squared times 3 to the 4th power, I could write that as 3 to the 2 plus 4 power, which gives me 3 to the 6th. Okay, so, the point of this, guys, is not for you to write this out every time. The point is for you to see the pattern, and when you see this, 3 squared times 3 to the 4th, then you automatically just write 3 to the 6th, okay? Or, do the math out here, all right? So that's the first one, all right? And let's write a rule for this, okay? So the rule that I have is if I had some number a to the m power times some number a to the nth power, okay, and notice how the base is the same, okay, this only works when the base is the same, then this would be a to the m plus n power, okay, so that's my rule for product of powers, all right, and that's my first one, okay. All right, now let's talk about the next one, which is called the quotient of powers. Okay, so we're going to use this whole page, and I just wanted to make sure that we understood this because a lot of times this is something that we often forget. So let's do this. Let's say we take 3 to the 5th power and divide that by, say, 3 squared. Okay. And what we're going to do here is we're going to do, say, 3 to the 5th. So I'm going to multiply 3 by itself 5 times. 4, 5, and then we're going to divide that by 3 times 3. Okay, so what happens is this, all right, if I were to take 3 divided by 3, this divides out to 1, okay? Sometimes we use the word cancel out, but I use the word divide out to 1. So 3 divided by 3 divides out. So then what are we left with? Okay, what we're left with is just 3 times 3 times 3, which gives us 3 cubed, okay? So the question is what do we do with our exponents, 5 and 2, to get 3? And what we do is we subtract, okay? So we can say that we subtract our exponents, all right? And so what we would do is, we'd write this like this. If I had 3 to the 5th over 3 squared, then what I would do to simplify this is I would take 3 to the 5 minus 2 power, which would give me 3 cubed. Okay, and that's how I get that. All right, so the rule that we would write, okay, so let's write a rule for this, if I had, say, a to the m divided by a to the n power, then that would give us a to the m minus n power. Okay, and that's my general rule. So, the cool thing about these rules is that this applies to really anything. You can use any number you want. All right, the rule is the same. Okay. All right, now let's talk about the next one. And the next one we're going to call power of a power. So power of a power. Okay. And so for this one, what I want to do, let's say I take like 3 squared and I raise that to the 4th power. Okay. Now, the long way of saying this is saying, okay, well, this means if I have 3 squared, okay, I'm going to take what's inside and I'm going to multiply it by itself 4 times. Okay, so this would really be 3 squared times 3 squared times 3 squared times 3 squared. Okay, and now what I have is I have 3 squared, all these numbers, and so when I'm multiplying these numbers with common bases, I add my exponents. Okay, so what this would give me is 3 to the 2 plus 2. All right, hold on. 3 to the 2 plus 2 plus 2 plus 2 power, which would end up giving us 3 to the 8th. Okay, so what I know is that if I take 3 squared and raise it to the 4th power, that's going to give me 3 to the 8th. So what are we doing? Okay, and what we're doing is we're multiplying our exponents. Okay, so we multiply the exponents. All right, and so let's take a look at that. All right, so if I take 3 squared and raise it to the 4th power, I'm really doing 3 to the 2 times 4 power, which gives me 3 to the 8th, okay? And that's what we're doing. All right, so my general rule, okay, if we were to talk about a rule here, if I take some number a, raise it to the nth power, and then raise that whole quantity to the nth power, all right, then what I'm doing is I'm just going to multiply my exponents, and I'm going to get a to the n times m power, all right? And that's my rule. All right, so that's what we got. Okay, so that's that. All right, now let's look at the next one, which is power of a product. Okay, so power of a product. All right, what I'm going to do on this one, let's use numbers. We don't have to use variables yet. So let's do, let's say I have 2 times 3, and we're raising that to the 3rd power. Okay, and what I would do, if I'm taking a quantity here, and there's a number of ways of doing this, but just to so you guys see how the rule works, if I take 2 times 3, raise it to the 3rd power, what I would do is I would take the quantity 2 times 3 times 2 times 3 times 2 times 3. Okay, multiply it by itself 3 times. All right, now when I do this, when I multiply numbers, and if I group them together, I can ungroup them and reorder them if I'm multiplying. Okay, that only works when you multiply. So if I rewrote this, I would write this as, say, 2 times 2 times 2 times 3 times 3 times 3. Okay, and if I have 2 multiplied by itself 3 times, really all I have there is just 2 cubed times their 3 cubed. Okay, and so what I'm doing, if I take 2 times 3 and raise that to the 3rd power, then what I'm doing is I'm just taking each of those parts on the inside and raising it to the 3rd power. So power of a product, and here's kind of the the general rule here. But if I'm multiplying, and the key is that you got to be multiplying these 2 numbers for this to work. Then each number on the inside is raised to the power. Okay, so My rule for this, my rule is if I take, say, a times b and raise it to the nth power, okay, then what I'm going to do is I'm going to take a to the nth times b to the nth, okay? And that's my rule. So you don't have to write these out every single time, and it's going to get to a point in this class where you're not going to want to write them out. But always refer back to this list. It'll help, okay? All right. The next one that I have is power of a quotient, okay? So power of a quotient. All right, and this one works very similar to the other one. Let's say I have 2/3 and we raise that to the 4th power, okay? What I'm going to do here is I'm going to take the value of 2/3 and multiply it by itself 4 times. So if I take 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3, okay, then what we're going to get, if I multiply fractions, I'm just going to multiply my numerators together. So this is going to be 2 times 2 times 2 times 2, okay, divided by 3 times 3 times 3 times 3. Okay, and if I have 2 multiplied by itself 4 times, that's really just 2 to the 4th power. Divided by 3 multiplied by itself 4 times is 3 to the 4th power. Okay, so if I have 2/3, all raised to the 4th power, then this is what we get. All right, so what we're doing is both the numerator and denominator are raised to the power. Okay, so the general rule that we would have is, if I had, say, a divided by b raised to the nth power, then what I would take is I would take my numerator raised to that power divided by my denominator raised to that same power, okay? And that's all we got. All right, so let's come out here. Let's box this guy up, and we'll ship him out. Okay, next one. And let's write this one over here. This one is interesting. Okay, so we're going to call this the zero exponent rule. Okay. All right, so let's do this. Let's say I have 3 to the, 4th power, and we're going to divide it by itself. 3 to the 4th power, okay? Now, what we kind of already know, and not kind of, we do know, that if I take something and divide it by itself, we get 1, okay? This is going to give us 1. Okay, but however, what we also know is we know this rule that if I take 3 to the 4th power and divide it by 3 to the 4th power, what I can do is I can simplify this. And I could write this, and I could subtract my exponents. And I could say, all right, well, I've got 3 to the 4 minus 4 power, which is going to give me 3 to the 0 power. Well, wait a second. So if I do this one way, 3 to the 4th divided by 3 to the 4th, I get 1. If I just think about something divided by itself, I get 1. But if I do the rule, we do it another way, we get 3 to the 0 power. So the conclusion that we can draw, all right, so the conclusion from this is that, 3 to the 0 power is equal to 1. Okay, and so what I can then say about this is that anything raised to the 0 power is 1. Okay, and that's what we get. All right, so if I, my rule for this, and this would be anything, okay, if I take some number a and raise it to the 0 power, it's going to give me 1. And that's it. Okay. All right, so let's box that up, and let's take this a step further, okay, which we're going to talk about the negative exponent. Okay, And so the negative exponent rule, let's take a look at this. Let's do this. Let's do 3 squared divided by 3 to the 5th. Now let's do this the long way. All right, so if I take 3 squared, it's really 3 times 3, and divide it by 3 to the 5th, so that's 1, 2, 3, 4, 5. Okay, and what's going to happen is that 3 divided by 3 divides out, 3 divided by 3 divides out, and in your numerator you're left with 1, okay, divided by 3 times 3 times 3, which is 3 cubed, okay? So that's a little interesting, okay? If I do it one way, the long way, I get something with a positive exponent. But let's use our rule that we know, okay? If I do 3 squared divided by 3 to the 5th, all right, then what I want to do is I'm going to take 3 to the 2 minus 5 power. Now, if I do 2 minus 5, that's going to give me negative 3. So it's going to give me 3 to the negative 3 power. So again, we got some sort of discrepancy here, okay? And so what I have is this. You know, if I do it the long way, I get 1 over 3 cubed. But if I use my rule, then I get 3 to the negative 3rd power. So what I know about these, what I can conclude is that these two things are the same, okay? In that what I would want to say here is that if I take 3 to the negative 3rd power, that's really the same thing as writing 1 over 3 cubed, okay? And that is pretty powerful, okay? That's going to help us out. All right, so the rule is, all right, so the rule is that if I have, you know, say a to the negative n power, then what I would want to do is I would write that as 1 over a to the n, okay? And that's my rule. All right, so, you know, the general rule of thumb on, you know, with a negative exponent, let's see what I got room for, okay? So my general rule, you know, let's just kind of talk about this. So if you have a negative exponent, all right, if you have a negative exponent, then you can move it to the other side of the fraction and make it positive, make the exponent positive. All right, so let's take a look at another example here, okay? Let's continue on with this. So let's say that I have, you know, let's just think of another example. All right, and how this works is, let's say I take, you know, 3 to the negative 2 power, okay? You know, this in itself is a fraction, okay? Anytime you have a number, you're always dividing it by 1, okay? And what I'd want to do, you know, and just follow this rule is take this value here, all right, I have a negative exponent. I want to turn that into a positive exponent. What I want to do is just move that down to my denominator, and it's going to become positive, all right? So that would give me 1 over 3 squared, and that's the idea. Now, similarly, let's say I had this, okay? Let's say I had another example where I had 1 over 3 to the negative 2, okay? If I wanted to make that positive, then what I would do is I would move that to the other side of the fraction. I'd take it from the denominator and put it in the numerator, and that would just give me 3 squared over 1. You don't really need to write it over 1, but this would just end up giving us 3 squared. Okay, so kind of an interesting, you know, set of rules that we've got, but, you know, they are important because they will, you know, you will encounter them. Okay, let's do one more, okay? And this is another negative exponent rule. So let's write this as negative exponents with fractions, okay? And we're going to kind of go the long way on this one. Let's say I've got, say, 2/3 to the negative 2 power, okay? So what I know about this rule is, and this one you kind of have to maybe do the long way every time, just kind of depends. But what I want to do is this, all right? I'm going to take each, the numerator and the denominator, I'm going to apply that fraction rule that I have, okay, the quotient rule. So I would take 2 to the negative 2 power, and then I would divide that by 3 to the negative 2 power, okay? And then what I would want to do is I would want to, take my numerator, move it to my denominator, and vice versa to make those positive. Okay, so what we would get is in my numerator, I would get 3 squared divided by 2 squared, okay? So there's kind of an interesting thing, another way to do it would be to say, all right, if I've got 2/3 to the negative 2 power, because it's raised to a negative, I'm just going to flip my fraction, and that would just give me 3 squared, okay, which would then give me 3 squared over 2 squared, okay, and you would get the same thing, okay, so you get the same thing in the end. So the cool thing about these rules is that, they all work together. And order doesn't necessarily matter unless you have to just make sure that you're doing the rules correctly, and then, you've got them. So, this video, guys, is just kind of a refresher, because this is something that we often forget. And I wanted to show you how we get the rules, before we just, I just let you loose on the rules. Okay, so, hopefully that this helps you understand what the rules are. And then we're going to take it a step further and use fractional exponents in the next video. Okay, so good luck, and we'll see you soon. Thanks a lot. Bye.